Hey guys, it's Michael with Breaking Concepts again, and today we're going to take a look at a quite interesting example for our discrete time model, and it's the methylation of DNA. And so, yeah, take a time and pause this video and try it out yourself. So, same as before, I'm going to show you the solution to this question, as well as sharing my failed attempts, on this question, like what went wrong, what was my thought process behind it. And so, let's jump right into it. So first of all, we can see that from the question, DNA sometimes has a chemical group, attached called a methyl group. And so a methyl group is basically a CH3 group. If we study chemistry, we'll understand that. And that affects gene expression. And suppose that during each hour, the first a fraction of unmethylated, so it wasn't coated with CH3. Locations on the DNA becomes methylated, and then a fraction U of methylated locations become unmethylated. And find a recursion for the fraction F of the DNA molecule that is methylated. And for those who are not familiar with DNA and methylation, basically, when a DNA strand has a bunch of what we call CH3 methylated group attached to DNA, that DNA is not going to be is going to inhibit proteins from transcribing it, and then basically it would inhibit proteins from transcribing it, basically stopping it from being processed into mRNA proteins, etc., etc. So for M, or that's unmethylated locations, right? But M is a fraction. Remember that it's a fraction, right? We can just think of it as like a percentage or something, right? A fraction of unmethylated, right? Unmethylated location on DNA, and then it becomes methylated, okay? And notice that it says first, right? That's the first step. Okay, and the second step would be that a fraction U, again a fraction, right, a percentage or whatever, of methylated locations becomes unmethylated. Okay, becomes unmethylated, and we're trying to find the fraction F, which is, again, a fraction of the DNA molecule that is methylated, okay? That is methylated. And so what we're trying to find is basically Ft plus 1, right? So I hope we kind of understand what's going on, and let's try and do the first step first. Let's try to crack this code first, okay? So we understand that this fraction of unmethylated DNA. And how do we find this? Basically, if you think about it, all we gotta do is just M times 1 minus Fn. And why is this case? Because think about it, fraction M is just a percentage. A percentage times 1 minus Fn. 1 minus Fn is the fraction of unmethylated DNA. And sometimes it might be confusing as to how can we treat fractions as whole numbers or whatnot. So imagine this. Imagine you have a DNA strand, and then this side, okay, this side and this side, the green one are methylated. And let's, for instance, I don't know, that the yellow part is unmethylated. So what we know is the F part, the green part, F means that they're methylated. Right? If you want to find the yellow part, all you gotta do is just 1 minus F, right? Simple as that. So therefore, we have here M times 1 minus Fn, which is basically you multiply this side by n, and this will gives you the proportion of DNA that change from unmethyl to methyl. And I hope that makes sense. Let me use this again, just to show clearly what's going on. And so moving on to second point, we have to be extra careful here. So what it says is after doing this, okay, and the reason why I point out after is that after this operation, a proportion of methylated becomes unmethylated. So now let's think about it. What does it mean by the portion of methylated? Well, we know it's going to be similar to something like we did on top, right? We have your U multiplied by something. But first of all, we have to remember that originally there's already a proportion of DNA that's originally methylated, and that's what we call Fn, right? We also have our newly methylated DNA, which is our M times 1 minus Fn. Let's look at this diagram again. Remember, green are the methylated, and yellow is the unmethylated. Now, let's do a blue color. The blue color basically says that some of those unmethylated has been turned. So that's step number one. It becomes part of the methylated group. They're the same, right? It becomes methylated. But then at the same time, after this step, the portion of all methylated DNA becomes unmethylated. So it could be a portion, I'll use yellow again. So it could be a portion like this. This portion has been reverted, and this portion, a small portion of the newly one has been reverted, and so on and so forth. So the reversion of DNA methylation is an addition of our original one as well as our newly updated one. So we're taking it as a whole and multiplying by u, the fraction of which the reversal process is happening. We can finally go to our answer and try and construct it. So we have ft plus 1 equals 2. Well, take a look at here. We have m times 1 minus fn, which is our first step. And we want a minus because the result of this is going to show you the portion of unmethylated, and we don't want that. What we're looking for is the methylated one. So we want to minus u times this one times everything that's inside. It's a long string of text, I know. And then we might be forgetting something. Yes, we are forgetting the original proportion of the methylated DNA. And the reason why I'm adding this is because look at this. This is the original, okay? And this is the additional, right, methylation. And this is the reversal, right? We're doing a lot of good work, but eventually somebody has to come and take that away, right? Or jeopardize it. So in a way. So therefore, we have this equation here, and I'm just writing again for clarity, ft plus 1 equals to fn plus m1 minus fn minus u in the bracket fn plus m times 1 minus fn, and then close bracket. So are we done here? We technically are, but we still have to do some simplification. So from this formula, you see that this is a term, this is a term. So we can take out the term and we can write something like this. Fn plus m times 1 minus fn would be equals to what? This is a term, and we took it out from 1 minus u. Okay? So now we have two terms here, and we can even simplify inside, and we can do fn plus m minus mfn. Okay? So, and then 1 minus u, and then we can do an even more simplification, do 1 minus m, okay, and then we're taking out from fn plus m, and then we have a big bracket, and then 1 minus u. So this is the final answer. So this is my previous attempt, and I'll tell you why it's wrong. And well, number one, you can see from here, our reversal function, all I did was just times the proportion by the original fn, but I forgot that we have received an additional batch of methylated DNA, and I didn't factor that inside. So that number one, that's false. That's not correct. That's error number one. And the error number two is I literally forgot to add fn. And the reason why is I guess I got too carried away, figuring out this one and this one. And so I forgot to add fn, which is the original batch of DNA. So all in all, this is the correct answer for this question. And I hope you guys enjoy this video, and there will be more and more amazing videos coming up. Thank you.